Yeah, it's great to be here. Good to see all of you. I am going to talk about machine learning for creativity, interaction, and inclusion. And I'm not going to assume any particular machine learning expertise or creative technology expertise here. So I'm going to start out really just with an introduction to the space. I'm going to show you some of the work that I've done in this space and then really give you a tour through some of my research findings over the last 10 years, examining how machine learning can be useful to human creators and why, and how to make it more usable and useful. And then I'm going to finish up with some current work, which is also a bit more speculative, around using machine learning for promoting inclusion and also improving inclusion within machine learning. So let's get going. So machine learning, most of you probably know, it's cool and fun and important. But if you don't know more than that, here's a good starting point. So you should think about machine learning algorithms really as tools for finding patterns in data. And an easy way to talk about this might be, well, I've got a web store and I've got customers and I collect demographic information about these customers. And then I can apply a machine learning algorithm to notice that there might be clusters of similar customers. And maybe I want to market to these customers slightly differently. Or maybe I also collect information about what they buy in my store, and I can use machine learning algorithms to make predictions that help me make more money in the future. So I might see that some customers buy one particular type of music album, for instance, and others buy another type of album. And when I see a new customer coming to my store, of course, I know lots about them because I've been tracking them on the internet. I can say, oh, you're going to like this artist. Please buy this thing, and they're going to buy it. We can also use machine learning algorithms to generate from data, to generate new similar content. This, interestingly, is not that useful for selling things to customers in this way, right? I'm not going to generate new virtual customers usually, but it is really fun with pictures of cats. So these are now just cats. And with enough pictures of cats and the right machine learning infrastructure, I can generate new pictures that are similar. And I will never run out of pictures of cats on the internet. So we've solved a big problem for humanity. Of course, you can do this with other types of content, and this starts to become really fun. One of my favorites is using the same type of algorithm to generate music album covers. You can do this with video. You can do this with audio. One of the now classic year-old projects in audio now is WaveNet. So this is the same kind of algorithmic approach, roughly speaking, but applied to a data set, which is a big collection of classical piano music. And so I'll play you the results of what this generative model produces. So it sounds like a piano. That's great. You can do this with text. One of my favorite people on the internet right now is Janelle Shane. Follow her on Twitter if you don't, because she's amazing. And she does a lot of creative projects finding text corpora to model and then generate. And so this is Halloween costume names. And you can kind of see here, it's learned some things about what we like as people for Halloween costumes. There's a whole sexy set of costumes. And then it's doing some things that you could imagine someone dressing up as that, but maybe a person hasn't thought of that before. By the way, I went on Google Images and Googled sexy lamp today. And this is the first result. I'm just going to leave it at that. You can buy it for $512. So this isn't perfect, right? You're not going to be fooled that a sane human came up with this content or compose that piano music trying to sound like Chopin. But these algorithms are going to get better and better. And sooner or later, maybe next year or the year after, we're just going to have a button, right, where we, as creative people, can say, I want some new content. I'm going to run this algorithm and then be done, right? So that's the end of my talk, right? And you're laughing, right? You're laughing. Hopefully, many of you are HCI people, and you might realize that this is a little bit limiting and short-sighted. You'll notice, first of all, my button has a couple asterisks there. The first caveat is that this works really well if you have lots of data, right? So these algorithms don't tend to work out of the box the way that I've shown you, when you have really small data sets. So that limits a bit the set of domains where you can apply these as is. It's also ideal to have a PhD, a lot of programming and math experience to get these things working if you want to do your own stuff with them. But more problematically, if you don't like what things spit out, your option in many cases is you kind of hit the button again. And so the interaction model here, if you think about how this is going to be used to create new content, is a little bit limiting, right? It's a little bit like, hey, you're doing a creative thing. Let me make a creative thing for you. However, so one of the things I want you to get out of this talk today is maybe a bit more of a critical eye when you see really exciting, funny machine learning systems that are out there doing creative work. I think they can be interesting for all sorts of reasons, but that doesn't mean that they're necessarily the right tools for human creators. And I also want to get you thinking about how there are all sorts of other opportunities, both with these generative methods and with other types of methods, to really support human creators in really interesting, exciting ways. So I've been doing research in this area for about 10 years now. I'm really interested in how machine learning can be used not to really replace people and give them this big red button, but to support people's existing creative practices. And so we can break that down a bit using those definitions of machine learning that I started with at the beginning. And we can ask, when might it be creatively useful to find patterns in data, to make predictions, to generate new similar examples? And I'm also really interested in making tools so that creative practitioners in different domains can use these techniques effectively in their own work, because I think it's really short-sighted and limiting if people with engineering, programming expertise are the only ones who can use them. We're going to end up with just less interesting stuff, for one thing. So one key to recognizing what all the opportunities with machine learning might be is to start by thinking about what might the data be, right? What kind of data could we use to do these things? And there are potential sources of data everywhere, right? A lot of the cool generative modeling techniques have used large data sets, large image data sets, and so on that either have arisen on the internet or have been carefully curated. And yes, those are really exciting, and they are really useful often. But there are other sources of data that are often just as powerful, right? Data that you could collect from sensors, from cameras, from microphones about what people might be doing at this moment, how they're moving, for instance. Or data that creators make incidentally throughout their work, right? If I'm doing photo editing, the whole set of photos that I've edited in the past, that's data. The sequence of operations that I do within the software as I work, that's data. We could model that. We could find patterns in that. That could be really fun. And then there's all sorts of data that might not be inherently creative, but which we care about a lot, things like our social media data or the weather. People have been making music and art out of these data sources for a long time. And machine learning gives us some extra infrastructure for dealing with that data in perhaps more useful ways. So let's just focus for the moment on this prediction paradigm, the same type of algorithms that we can use to predict which album someone's going to buy. We can use that in other contexts. And for me, I got really interested in using machine learning with sensors and with real-time interactions. And so instead of saying, well, here's demographic information, here's what they're going to want to purchase, we could say, well, maybe we're going to listen to what sound is happening in the world, or what sound is coming into a microphone, and then use that to drive some kind of computer action. And maybe this is a music visualization, or maybe this is a voice-controlled game. Lots of different things could fit into this paradigm. Or the place that I really dug into when I was a PhD student was this, to say, well, what if we take information from sensors that give us data about how people are moving and predict what sound we want the computer to make? Right? And we can use this supervised learning infrastructure to make some cool stuff. So I'm now going to give you a demo of the software that I made starting in about 2008 to make it easy for composers to build new musical instruments with sensors. And you can use this in all sorts of other domains. It's been used in a lot of different projects at this point. But it gives you this basic infrastructure where you start out and say, I'm going to capture some data from the world, or maybe read it from a file. But it's more fun if you're getting it in real time sometimes. And I'm going to send that to a predictive model. And that model is going to give me some kind of output that I can use to choose which sound to play or control the parameters of a synthesis algorithm or control how a robot moves or whatever I want, right? And this is modular. This can be any software on the bottom here. And of course, more interestingly, Wekinator doesn't just limit you to taking someone else's model that has been trained by an expert to do a particular thing. It allows people, even if they don't have programming or machine learning expertise, to build that model themselves. So let's start out with a demo. So the first thing I'm going to show you, oops, not that one. I like this example because I'm going to run, for this first component, the world's worst computer vision system. And we're still going to be able to build something useful with it. So this is just taking my webcam input, chopping it into 10 by 10 grid cells, and sending that data out as a single flat vector. So if you're a programmer, even if you're a really good programmer, you're not going to be happy if I say you have to write some code that looks at those 100 numbers and says something useful about what's happening in front of the camera. You might be able to do it, but it would be really annoying. So instead, I'm going to use Wekinator. I'm going to use supervised learning to build a predictive model. And I'm going to build a classifier. And I'm going to use this classifier to control a drum machine. All right. And so I don't have a data set to start with, right? There's no ground truth data set of how I look in front of this camera in this room to control this sound, but I can make that. So I'm going to start out by saying I want this sound to happen when I'm standing here. And I've just captured 15 examples. That's it. And now maybe I want another sound to happen when I'm not standing there. And I'm going to build a machine learning model, and I'm going to run it and see how it does. OK, so it's working pretty well. And if I move around, I can see, well, it's making a mistake right here. And that's OK. I can give it more examples and say, this is still me. Now, please run. And it's, yeah, maybe I want to fine-tune it and say, this is also still me. And I just keep iteratively improving the model by adding some more data. And if I'm happy with it, I can maybe make it more complicated. I could say, well, here's another thing. There's my hand. OK, so that's building a classifier to control sound. Pretty straightforward. Pretty easy. Like, as you can see, I didn't need to know much about machine learning to make that work. And it worked even though I had really horrible data coming in. I want to give you another example of how most composers use this when I started building this into a tool for them in 2008, 2009. And the music that I was playing for you just now, you could play that same music with a few buttons, right? It's creatively not giving you lots of different musical expressive possibilities. However, there are lots of things that are hard to control with buttons, right? If you have lots of different parameters of sound changing at once, that starts to become musically more of an interesting possibility space. So most composers weren't using classification like I just showed you. Most of them were very interested in regression, and regression with predicting multiple continuous values at a time. And likewise, most of them weren't using this crappy webcam input. They were interested in using different kinds of sensors that might give different information about how people were moving or acting. So here I'm going to use a leap motion, just use the shape and position of my hand to control some sound. And I'm going to open up a fun little music program, which is going to allow me to do some manipulation of an audio sample, if it loads. There we go. So I'm going to OK, so there's my audio sample. And I might say I want to use my hand now to control how this sample gets played back. And maybe when I put my hand, I'm going to show you there. When I put my hand kind of just a few inches above this, I want this normal sound to happen. And maybe I want the pitch to go up as I move my hand up. So I'll give some more examples with that new position and that new sound. And now I have a continuous pitch controller, which is kind of fun. And I can start making this more interesting and say maybe I also want different hand shapes to really do crazy stuff to the sound. So maybe I like that, and I want a sort of claw hand over here to give me that sound. And I can put that in, retrain with those additional examples. And that's kind of cool. Maybe I like that, but maybe I want to do some other totally weird stuff. Like that's a neat sound. And maybe I'll put that over here somewhere. All right, so that's you get the idea. Pretty easy to build a new interaction that way. So that's the end of the first part of my talk. Does anybody have any questions about what I was doing right there? OK, everybody more or less gets it. If you want to, yeah.
What camera are you using?
So this was a Leap Motion with that was the thing getting my hand. So they're you can buy them for $40 or something. Yeah. Yeah.
The regression one, if you have like too many things which are just like can you like make it such that like you have like a lot of things which just don't really not fittable, like the data, like what happens to music?
Yeah. So there are all sorts of really interesting questions here about certainly different learning algorithms are going to allow you to learn different things and not others, or might require different amounts of data to learn different things. I can talk more about the details of this in the question period, but one of the things that I did with Wekinator is the first version of this I built using a set of really intense participatory processes with composers to try to figure out like what is a reasonable default to put in there that's going to be able to more or less learn the stuff that I saw people doing. And so the hidden sauce under the hood is the choice of algorithm and the configuration of that. And so I can talk about that in more detail later if you want. I've also been working with people, observing people using this software for a long time now, and continually kind of trying to understand, again, what is it that they're doing? Are the configurations the defaults? The way that this is set up, the number of models, is that a good match to what people really want to do? And how can we make it better? So actually that leads into the second part of my talk, which is really not just how do we make stuff like Wekinator that's usable. That's part of it. But what do people use this for? What is it good for? How might it support different types of creative practices? And because I'm giving this talk in a computer science building today, I've got a little bit of stuff thrown in here about how using machine learning in this context to build things ends up looking a little bit different from using machine learning in more conventional applications. OK, so I've got sort of 5 really high-level research findings that I want to throw at you. And again, we can go into more detail in any of these in the question period if you want. So the first really exciting thing for me when I started this work as a PhD student was that people immediately started using it to build really weird stuff that I hadn't expected, and especially started building interactions with sensors. And so I want to give you a couple examples so you can see that it's not just like weird claw hands making weird sounds. There's actually some really beautiful music that people have made, for instance. This is a piece by a composer who, she's using these controllers. These are actually PlayStation golf game controllers, but she's having people play music with it. I'll leave it at that and just play the video for you. Oh, no. Go away. Oh, hold on. I'm totally stuck. PowerPoint has frozen. Oh my gosh. All right. We may never get out of this presentation, but that's OK. There we go. Here's Anne's piece. So you'll notice a couple of things here. One of the reasons I really like this piece is, I mean, the sound is lovely, but the experience of watching that piece being performed is totally different from watching someone, doing electronic music by standing in front of a laptop and typing and using a mouse. And also the types of movements that she wanted in this piece. She wanted performers to do something that's very much like a yoga sun salutation sequence. She was able to build that pretty easily with machine learning to say, here's how I want the performers to move, here's how the sound should change as they move. Whereas that kind of instrument would be a lot harder to build using programming. Another one of my favorite really early interfaces that somebody built was this one. This is Michelle Nagai, who's a composer who walked down the street one day and saw a piece of tree bark and said, I need to turn this into a musical instrument. So she brought it home, put light sensors in the bark, and built an instrument that she plays by casting shadows over these 25 or so light sensors. So again, this is a really beautiful instrument. You can watch her play it on Vimeo. But it's an instrument where it just wouldn't have been feasible to build to get 25 kind of weird, noisy inputs that are also really impacted by the lighting conditions in the room and so on. She was able to make this quite easily with machine learning. Since then, people have been using Wekinator for all sorts of other kinds of projects that I didn't envision, which I think is great. This is an art project featured in Motherboard by a student who you put a camera on your head, and if that camera detects something that looks like a screen, then it takes special glasses that you're wearing and makes them opaque. So you cannot look at a screen while wearing these glasses, which is pretty cool. I've also used Wekinator in a lot of teaching, both teaching my students at Goldsmiths and teaching interaction design to people who may or may not have done programming with sensors before, but also teaching workshops at various other universities, conferences, workshop locations, and so on. And a lot of the things that people have made end up being just really fun and kind of whimsical. This is HiBot. This is all it does, is you wave to it and it waves back. And I like that, for this, the hard part of this project was thinking about what to do, gluing the servo motor behind the cardboard and not actually saying, well, I need to now figure out what is a wave computationally and find that, write the code to identify that. So there's lots of other really cool projects that people have done, everything from sort of rock, pop music to puppetry to starting companies with apps that react to you in really intelligent ways. And I'll talk about some of the work I've done in the accessibility space. I could give a whole talk on this. I'm not going to. You can go on the Wekinator website or YouTube, Vimeo, and see some really cool stuff. But again, lots of the really fun projects are projects where people are using sensors and making things that might be really hard, or at least annoying and slow to make without machine learning. Now, the second point I want to make is that building these types of interactions with machine learning, especially building creative interactions, but even building things that might be not very creative, requires a few differences in the interfaces that we give people and the way that we think about the role of the algorithms. So in conventional machine learning context, the way that you would learn about machine learning in a computer science class, usually the goal of using machine learning is to build an accurate model of your data so that perhaps you can make predictions on new unseen data in the future, right? Super useful. If you build that model and it doesn't work very well, often you're going to change the algorithm and find a more suitable algorithm, or you might change the features, or you might say, oh, I've got more data that I can collect and use a bigger data set. That might often help as well. But you don't want to mess around with the data too much, because the data, you talk about it as a ground truth, right? It embodies some sort of truth about the world that you don't have access to other than through the data. When people are creating interactions with machine learning, a lot of these things change, right? People still might want to build a controller that they would call accurate, right? There's, for instance, if I want to build a gaming controller that reacts to me, punching, I want it to always react 100% of the time and not react otherwise. But that accurate controller is in the context of a larger goal, which is I want to play a game that's fun, that's accessible to people, that doesn't take practice to learn how to use. Or maybe I want to build an expressive musical interface that gives me cool sounds that I can play on stage without looking stupid, right? There's all sorts of other subjective, complex goals here. And sometimes changing the algorithm or features are really good ideas, but often changing the training data is the most effective and reasonable way to change what the model is doing if it's not doing what you want. So you saw that in the camera example, right? When I found a place where it made a mistake, I was able to easily correct that by just giving it examples. I'm like, oh, I overlooked what it might, what I should tell it to do when I'm standing here, so I can fix that and retrain, and we're good. And so in HCI, people often talk about this as human-in-the-loop approaches to machine learning or interactive machine learning. Machine learning researchers may mean something slightly different when they talk about interactive machine learning. And the reason that this makes sense, so it's a complicated conversation, but one of the reasons is that this data often, there may be some kind of hidden truth in it that we can't articulate otherwise, but the data is really sort of user interface or communication channel between the person and the machine, right? It's my first training set is my way of telling the computer what I want it to do. And my subsequent training sets might be refinements of that, those instructions about what I want it to do. And so this actually requires some rethinking about what it is that we want the algorithm to do, what makes a good algorithm, and of course, how we structure the user interface, right? Most other software environments, especially software environments for non-interactive, not more conventional machine learning, don't make it this easy to mangle your training data, because that's a bad thing. Wekinator, I learned right away that was going to be super useful for people. So we need to have interfaces that allow the kinds of manipulations that make sense. But this leads to some interesting computational consequences in that people are going to provide training data that is not IID, right? This is sort of an assumption that often we make for convenience and maybe even with good reason when we're talking about machine learning theory. But people, turns out, are often smarter than that. And if we allow them to be smarter, we take advantage of the fact that they're smarter, we can learn more efficiently. So let's imagine we're building a musical instrument, and we're looking at maybe where my hand is in space, and I want one sound to happen when my hand is in the purple and one sound when my hand is in the orange. If I were doing this in a more traditional machine learning context, I might go out and collect a bunch of data, try to get the best data set possible, and get a nice even sampling maybe from these two regions. And that would be a pretty good, if small, data set. When people are using Wekinator to build examples, even when they don't know anything at all about machine learning, often they'll start by giving just a few examples, maybe in the center of the purple and the center of the orange, more or less. And they're not going to spend too much time worrying about it. And then they'll build a model and see where that decision boundary is. And if it's not exactly where they want, they're going to add some corrective data. So they may say, well, this is really purple, and this is really orange. And now I'm going to retrain and get my boundary, keep testing, keep doing that. But here, what I've done is I've learned essentially the right decision boundary, but I didn't have to provide all these other examples. So it's kind of like the same benefits that you would get from active learning, but here, instead of the algorithm saying, hey, please label these unlabeled data points, it's the person just doing what they naturally do and saying, I'm going to find where it makes a mistake, and I'm just going to give corrective examples there. And of course, that only really works if you have an algorithm that's perfectly willing to trust that person and say, yeah, even if that purple dot were way over there, maybe I trust you, and I'm going to give you a super weird decision boundary and do what we would normally call overfitting. Turns out if you try too hard not to overfit in many of these interactive contexts, people take that sort of personally, and they say, well, the algorithm's not listening to me, right? I know what I'm doing, and it's still not doing what I want. Another consequence of building the interface this way, and this was something that really I hadn't thought about at all until I started working with people and observing how they were using the software, is that people were using these changes to the training data not only to fine-tune the decision boundary and correct mistakes, but actually to try out different hypotheses about what they might build, right? So they might start out with an idea, the way that I did with the leap motion, and say, well, what if I put this sound here? What if I put this sound there? And as soon as I have that, then I've got a prototype. And I can play around with it. And I can use my experimentation with that right away to say, well, was that a good idea or not? If it was a good idea, great. Maybe it was a good idea, but I found some other sound in there that I really liked, and I could put that back in the data set. Or maybe I didn't like it, and so I can roll back, and so on. Right? So we can think about these changes to the data set as also, again, people communicating hypotheses about something that might be fun. Or likewise, people exploring and saying, hey, I have an idea of a thing that might be cool. Is this learnable? Is this going to be learnable given the fact that I'm not willing to spend more than 5 minutes giving training examples? Right? And people often are involved in this negotiation with the algorithm to say, well, what's the most useful thing I can build in the amount of time that I have? So of course, we can think about these as all really valuable types of activities in any kind of design context, right? Supporting rapid prototyping, supporting exploration, recognizing the fact that people are in a dialogue with the materials that they're using, and allowing them to have that dialogue and explore and experiment, rather than assuming that, oh, this is ground truth training data and it's never going to change. So I did a project with a student a few years ago exploring this and saying, well, what if we were to make user interfaces for design with machine learning that assume from the get-go that you're going to change your mind and make it easier for you to reason about what alternative designs might be good ones or might be problematic. And in the meantime, also make it possible to control sounds by beatboxing, because that's fun. In a more serious long-term project that just finished up, I've been working with a bunch of startups in music tech and gaming around Europe. And this project was a 3-year effort called Rapid Mix. And we started out really recognizing that using interactive machine learning to build interactions is really powerful. It's powerful as a design tool. But Wekinator isn't for everybody, right? Wekinator is good for teaching. It's good for building musical instruments. Not so great for software developers who want to build their own app or want to build their own game. And so we started, my portion of the project started with asking, well, what might it look like to build tools for developers that allow them to engage in the same kind of experimentation, to build tools for developers that they can use without having to go take a machine learning course first. I don't think we've answered all those questions. These turned out to be really difficult questions. But the current answer that we have is embodied in this Rapid Mix API, which you can use in C++ or a couple other environments, open frameworks, MaxMSP, if you're a programmer and you want to do this kind of stuff in your own projects. Yeah, Michael.
Just a couple sentences about what was your point of view on how one designs an API?
Yeah.
Developers use interactive.
Yeah. So I have a PhD student who's still got a little bit of time left who was looking at this and saying, well, clearly we don't have a guidebook that you can use to write a good API. There's lots of research that's been done on what makes APIs understandable or learnable, and we built on that, but machine learning is kind of its own beast in some ways. And so one of the things that we were doing was developing participatory processes to work with developers at these companies, as well as with creative coders and people at hack days and so on, to throw tools at them and get feedback on them and kind of build up a better understanding of what is it that they're looking for. Everything from really practical stuff, like which programming languages do we even target to meet the needs of this community, to what ended up being one of the most important questions: what do we need to teach people about machine learning before they start? And can we make online integrated tools where they have some tutorial and a self-explanatory demo in the environment? So if you go to the website, one of the things that we did on the website is have embedded code examples in JavaScript. So yeah, we'll hopefully have some more papers coming out about that soon. We've got a short paper about that right now. All right, next point I want to make is that these tools ended up, when I asked folks that I was working with, why are you using machine learning? Often it wasn't the answers that I just started with. It wasn't answers about, well, I have sensors and they're complex and I can't build something otherwise. Often it was about the way that they were able to think when they were engaged in designing interactions. So the people using Wekinator are often people who are making music or who are moving or thinking about sound or animation. And even if they're really good coders, they find that there's a challenge in moving from thinking about how you want to move or how you want something to sound to turning that into a mathematical equation. And if we can give people example-based programming interfaces, then they don't have to make that cognitive leap back and forth, which slows them down and gives them stuff that they're less happy with. I want to mention not just this is something that's been important not just in the Wekinator project, but in several other projects I've done with students. This idea of how data can provide a foundation for building computer systems that understand something that we are doing, something that we're bodily engaged with. This led my former PhD student, Reed Oda, to do a really cool project recognizing that if we look at how a percussionist is moving a drumstick over time, we can actually predict pretty accurately when the next drum beat is going to happen, even if they're not playing at a steady tempo. And we can take this information and maybe send it over a network before that hit happens and enable completely latency-free collaborative performance. So I can be hitting my drum in New York, and somebody in Tokyo can hear a sound of that drum synthesized in exactly the same time, even if the network is introducing some speed of light delay in the best case. So that was a cool project. Last thing I want to say about sort of my research findings is that there's a whole space that I'm excited about right now, looking at how machine learning does change people's possibilities for creative practice, right? So far I've been talking about how it supports things that people naturally do sort of with any medium, but there are things that I think machine learning makes it easier to do that change people's relationships with their tools, and some of these are potentially very powerful. Now, a lot of the tools out there that are getting media attention or going viral on social media are really tools that make it easier for people without expertise in some domain to generate content in that domain. And there are some commercial products now arising in this space. This is JukeDeck. This is a London-based music tech startup where you can make a song by choosing what genre, what mood, duration, when you want the climax of the piece to happen, and then it'll make you a song with a name as well. And so here I'll play you, this is my aggressive synth pop track that it made for me. Okay, so you go try this out. This is free to try. I'm not going to torture you with the rest of this track. It's not the worst music in the world. It's definitely not the best music in the world. So this, again, I don't think anybody's really, thinks that this is going to replace human composers. So I wouldn't say that it's a tool for creativity in that way. However, I think this is an awesome tool for YouTube video creators who might not be composers, might not have the money to hire a band or pay for the rights to a particular track. This allows them to put original music in their video without having expertise and probably come up with a slightly better end result, right? So they're delegating something that isn't really central to their goals and isn't really matched to their expertise. They're delegating that to a computer, and I think that's useful. There are a lot of other kind of tools out there. This is Edges to Cats. This one allows you to sketch sort of a line drawing, and it'll fill it in with the closest thing to a cat. And again, I think the target, I don't see this exact thing being very useful to professional artists. But probably we're going to see other tools that allow similar types of interaction which might actually add value. And actually, I want to skip over to this. This is the smile vector. So this is somebody using deep learning-based approaches to make random people on the internet and historical figures smile, right? And this, again, this is kind of cute, but this is useful, right? If you say, I want to manipulate content, maybe I'm a professional artist or graphic designer and I want to manipulate content in a believable way, this gives me a set of tools to maybe make my life easier, make me able to do things more flexibly. Back to the Edges to Cats thing, I do want to say there is very interesting work being made with this, not to make cats, but to make other things. So you've Batman cat, and really a lot of my favorite work, my favorite creative work with machine learning on the internet, I enjoy because it's people really taking advantage of the ways that these algorithms break down and exploiting that in creative ways, right? So the machine isn't being particularly creative here, but the people are saying, hey, I can appropriate this and do something with this that, if you wanted to make a serious artist statement, you could say something halfway reasonable about how this is a commentary on human and machine creativity and collaboration or something. Or, maybe it's just Batman. There are other artists doing really, serious work with machine learning. And if you talk to them or study the ways that they're using these tools, it is often quite different from using programming or using analog materials. So this is one of my favorite artists, Mario Klingemann. He uses neural nets to make visual art. He's also a very gifted programmer, does all the technical stuff himself as well. So arguably, a lot of his art making is acting as a programmer. But he's got neural network-based systems that give him lots and lots of different content. And when he's making work, he made himself a Tinder-like interface to sort of swipe right or left based on whether he liked the thing that came out, right? So he's, at least in part of his art practice now, acting as a curator rather than as the person deciding which color goes where. One of the musicians I've worked with for a long time now, who I've learned a lot from, is somebody named Letitia Tsunami. And she's been using Wekinator for about 6 years. And she's very critical of this idea that when we make creative tools, that they should be tools that always do, they allow us to most efficiently impart our commands to them, and they follow our orders, right? She says, in a way, you don't want the instrument to perform like a well-trained animal circus. You want it to be a little wild. You want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away, and then this thing is going to do that, and leaving it at that. Right. And again, I think lots of artists engage in different work with different media will say, if they're speaking honestly, that the work that they make isn't always just that they had a brilliant idea and then they were able to use their expert skill to make that idea, right? People often get inspired by things that happen with the materials that they're working with that they didn't expect, but which they know to take advantage of and incorporate into the final piece. And again, I think some of the nature of the mistakes or oddities that you can find in machine learning may make these surprising pushbacks from the algorithms more fruitful than perhaps when you're coding. And the surprise is that you get a compiler error, right, which is not likely to be creatively enriching. So I have another side project with a student where we said, well, what might it look like to make these interactive interfaces where instead of trying to use machine learning, anything resembling the right way, what if we just try to make something that always is going to surprise you, where you grab a sensor, you move it around, and then it makes you a mapping. So that was a fun project. All right, so for the last few minutes, I want to talk about what I've been thinking about in the space of using machine learning to improve inclusion and access, and also improving inclusion in terms of who gets to use machine learning, who gets to talk about it, and so on. And in a lot of my work, one of the exciting outcomes that I've tried to focus on and learn from and do more of is looking at how machine learning can enable more people to be creators. So I do a lot of workshops. These are high school students, for instance, who didn't know about machine learning, didn't know how to code, didn't know anything about computer music, and I was able to get them building computer music instruments in an hour or so. And then later that afternoon, they taught the 8-year-olds in the classroom next to them how to build things. And this is exciting, right? And arguably, a lot of the tools that you see online, things like Edges to Cats or Neural Doodle, they also allow more people to become creators. But I want to, again, caution that I don't think that's where the creative value of these systems is, because often the ways that these systems use data are to give you good training wheels or guardrails. And they're going to say, well, we assume that you want to have some kind of typical, realistic output, and we're going to give you that for free. But they don't give you a lot of ability to say, well, no, that's not what I want. I want something that's totally different and my own. So I think the space of interactive machine learning, whether that's iteratively changing training data or giving people other ways of influencing what an algorithm does and how, have the potential to be much more flexible and also allow people to personalize systems in new ways. So I have a project finishing up right now with a bunch of music therapists who wanted to use Wekinator-style interactive machine learning to build musical instruments. And we've got an open source project here. We're going to release the final version next week. And this has been super fun. They're building instruments for kids who cannot play most acoustic instruments. And more interesting than that, they're not just building personalized instruments that are playable. They're actually developing a curriculum that takes advantage of the fact that they now can make a new interaction with sensors and sound in about 30 seconds. And so they often make many interactions for different reasons in the context of a session with a kid or a classroom teaching session. I've got a current project with Microsoft Research, which I can't say much about yet, but we're looking at a lot of these techniques in non-musical contexts, saying how could we enable people who are blind and visually impaired to customize, personalize computer vision systems to get information that they really care about from the world around them. And so these projects have really gotten me thinking a lot about how this work might be in dialogue with what's in the news recently, right? Most people in the world, when they experience data and machine learning, it's as people whose data is being sold, or they're being disempowered, or they're being manipulated by it. And I've been starting to think about this question, what can we do as computer scientists or HCI researchers or designers to make people's experiences with data and machine learning less disempowering? Because there are all these other ways to make, to give people value from data that they create. What if we were able to give people more value from their social media data or their other data, for instance? And how can we get more people involved in the conversation about how they want machine learning to be used when it comes to their lives? So in this vein, I've been involved increasingly in machine learning education efforts. I've had a MOOC online for about 3 years now, exploring how we teach machine learning to creative practitioners. And that's been super fun. I'll give you a hint, it's different from how I would teach it to a computer science class. And it might actually look really similar to how I would teach machine learning to a non-creative group of people from the general public as well. And in fact, if you haven't seen Google's Teachable Machine demo, you should go look at that. They explicitly modeled this cool web app on the interaction that Wekinator gives you, but you don't have to download anything. It's just a website where you can go and understand what supervised learning is doing and make cool interactions with it. So I think there's a lot of space to explore, both how creative applications of machine learning might be useful in teaching people about what these algorithms really do, how they break down, but also thinking about, for instance, how applications of machine learning that foreground the impact of choice of training data in the output of the model, how that might be used to inform conversations about algorithmic bias, for instance. And the last thing I want to mention is that I recently learned about a really cool project in LA, which I had nothing to do with, but they used Wekinator in their work. They're running a bunch of workshops with folks around LA to build new technologies and learn about machine learning, and especially teach people who are not computer scientists, are not in the tech industry, people from various community groups, lots of them women, to teach people about what machine learning is and allow them to build things that accomplish something that's important to them. So one of the things they built was a virtual protest environment for people who couldn't, leave their homes because of disability or carrying responsibilities and so on. This allowed them to actually interact with this virtual environment together. So that's called post-human AI. So check that out as well. So with that, I'm happy to take any questions about any of the stuff that I talked about. And if you want to build some stuff with me tomorrow morning at 9:30, you should come along. You can also download Wekinator for free at that website. Thank you.
We have a few minutes for questions.
Yes?
It's interesting when you played the music that was sort of created based on other music we already know.
Yeah.
And you were like, that's not really interesting. And I think a cultural critic would say, well, that's because oftentimes when we think of what is brilliant or genius in creativity, it's something new, and it's something we have never seen.
Yeah.
And so do you think that would limit us ever in that it seems as if we were to use current ML technologies, we would always need a human being to kind of push it because we wouldn't know what is new versus.
Yeah, that's a good question. I mean, I want to challenge that just a little bit. I think it was the juke deck stuff that you're talking about. I think my beef with the juke deck song is not that it's not new. It's that it actually feels a little bit off to me as a musician. It's new in a way that isn't how a human would do something new. And I think that's going to get better. That said, even in the current juke deck system, there's a lot of human infrastructure and human expertise that's gone into, how to set that up. And it's not just, a standalone machine learning algorithm that's spitting out stuff. There's all sorts of human heuristics and constraints that are built in, and that's the smart way to do it. I think that's going to always be part of these systems, as far as I can see, into the future. Because why wouldn't you do that if you're trying to make money and make stuff that actually sounds good? Yeah.
I'd love to hear a little bit more about the different experiences you had holding workshops with creatives versus developers. Just what are some interesting differences you observed?
Yeah, I mean, I do want to be clear that the developers I was working with, that I have worked with, are primarily, they consider themselves to be like creative coders, or they're working in creative industries making apps or sound stuff. So it's not like they're making finance apps or something. Yeah, it's a good question. Not the question anybody's asked me before, so thank you. I think, in workshops, in both cases, my learning goals for people have often been, I need to get it clear, like what is the workflow of machine learning? What is the basic model of what we're doing? And that's, I showed that to you kind of early on in the slides, and that the simplest way to express this is you've got some inputs coming in, and then you've got a trained model, and you've got some outputs coming out. And the other thing that I tend to talk about with people or put in educational materials before a workshop is that, this model, you would normally write code to make that input to output function, but instead we're going to build that with examples. And so that's the place that I start, whether I'm working with developers or whether I'm working with 15-year-old kids or with Wekinator or whoever. And that's, people usually don't come with that knowledge already. So I think that's one of the things that we've learned is not even about how to pitch that to developers versus other people, but how to do that kind of education about really functionally what are these algorithms going to be good for, and how do you embed them in an architecture of a larger system? Because what I want to do is get people to the point where they can quickly imagine what they might build with that. And getting people to imagine things that are feasible is really challenging in both those circumstances. And I think probably more so with developers, right? When I'm running a workshop with creative artists and so on, I give them a lot of examples to work with. But developers, I give them example code, but they suddenly, they know they can push that into a domain that they're more familiar with, but they don't have an intuition about like what features might be good. How do I test this algorithm? Is this something I can do unit testing with, and so on? There's a lot, their expertise means that they're asking really hard questions much sooner in some sense. So educational materials interspersed with our API documentation have just been really, really important.
One final question.
Yeah.
With regards to debugging a complicated model in Wekinator, you can obviously just add more training examples. Do you try to do anything explicitly to help people relabel data that might be incorrectly labeled?
Yeah, so not in the regular Wekinator interface, and that's something that the Beatbox project, we started thinking about, like how might you help people notice that some of their data overlaps in the feature space, right? Which might be indicative that it's mislabeled, or that the way that they've defined their classes is inherently problematic given the features that they have. So in the regular Wekinator application, I haven't done that for various reasons. But if you haven't looked at Kara Patel's work, for instance, I mean, he explored that in more conventional application contexts with software developers, and I think James worked with him on that a bit. So that's, I really found that work inspiring, and I think there's lots more to do there, and more that people at various companies now are thinking about how to build into their machine learning tools.
Rebecca has a few minutes now. If you
Yeah.
have additional questions, feel free to come and speak with her. Don't tap her. Speak with her afterwards.
Yeah.
Thank you.
All right, thanks, Michael. Thank you.